everyone, as you know, I am Paul, your e-hobby guy, and today we are going to look at how to make this portable Bluetooth speaker. You can even mount it on a flexible tripod like this, not just to point the sound in the direction you'd like, but to mount it in places where you would not normally think to mount it, to bring the music closer to you, all for a more enjoyable listening experience. It is easy to make, it's inexpensive, and can be made with just some basic skills and a few basic tools. I will go through the full build, the complete electronics, the housing, and putting it all together. We will even compare it to some other well-known store-bought speakers. So stick around and let's jump right in. Here is a list of the electronic items that you're going to need in order to complete this project. First on the list is two 18650 lithium-ion batteries. Next is one TP4056 charging modules to charge the batteries. Next is the amplifier. It's a PAM8403 2-channel 3-watt Class D amplifier module. And the speakers are two 2-inch full-range speakers. Next up is the Bluetooth receiver module and its breakout board. I bought these separately, but you can buy them as one piece. I'll leave search words in the description down below. We need hookup wire, solder, a red, blue, and green LED, a 1/8 inch stereo audio cable, a 2.1mm panel mount barrel connector, and a 2.1mm male barrel connector for charging. You can download this entire list in the description down below. So, before we begin building the circuit, we'll take a quick look at the schematic so that we have a full understanding of what we're doing when we do build it. And so, looking at the schematic, over here we have the 5 volts DC, which is a standard plug-in power supply. This is going into the charging module, the TP4056. This charging module charges the batteries, but also controls discharge. And so the power from the batteries comes back through the module and comes out to power both the Bluetooth module and the 8403 amplifier. I have a whole other video that I've released in the past that describes clearly the charge and discharge of these 18650 batteries very safely. And so if you haven't seen that, I highly recommend you watch it. I'll leave a link in the description down below. The battery is now powering both the Bluetooth module and the audio amplifier. The Bluetooth module is receiving audio in after it's been paired up to a device and sends the audio out to the amplifier here. The amplifier simply puts out the audio to both the left and the right speakers. And so, enough with the schematic, let's move on to the fun stuff. This schematic will be available. There will be a link in the description down below. The first thing I'd like to take a look at on the electronic side is the Bluetooth receiver module and its breakout board. As I stated earlier, I chose to buy these separately and to solder them together, but you can buy them separately, but I highly recommend that you do buy them pre-assembled as one complete unit. It was a little tedious, but with some care it worked out just fine. Next we will take the 1/8 inch stereo audio cable and cut it to about 6 inches in length. Strip the outer jacket about 2 inches back and you will find a braided wire. This would be the ground wire. The red wire and the white wire are the left and right audio wires. Strip the red and the white wires back about a 1/2 inch each and then tin all 3 wires with solder. The 1/8 inch audio cable can then be directly plugged into the Bluetooth module. As for the power for the Bluetooth module, I cut this green micro USB cable and I stripped the wires inside. The 2 outside pins of the micro USB connector are the power pins. And so I did a continuity test like this to see which wire was the positive wire. The negative wire is the braided wire and can also be tested by touching the outside metal body of the connector. It turns out that the orange wire is the positive wire. And so I plugged it into the Bluetooth module and applied 5 volts just to be sure that what I found is correct, and it was. I then soldered about 6 inches length of wire, red and black for the power, onto the amplifier, and red, black and green to the audio out from the amplifier, with black being the negative, and the green and red being left and right respectively. And now for the battery charging module. I tinned the 6 terminals and prepared 3 red and 3 black wires to be soldered to the board. I soldered a red and black to the power in, a red and black to the battery, and a red and black wire to the power out. Soldering these wires individually onto each module allows me to interconnect the modules later by twisting the wires together, and this allows for more serviceability if there are problems later, before or after it gets put into the housing. Here are the two 18650 batteries. I hot glued both of these batteries together to keep them permanently bound. I then bridged both the positive end and the negative end with heavier gauge wire, first by tinning both the battery and the wire to make it easier for soldering. I then soldered a red positive wire onto the positive end and a black wire onto the negative end, about 8 inches in length. There is a red and blue surface mount LED on the charging module to display the charging status, and so I tested each LED for polarity so I could remove the surface mount LEDs and replace them with my standard 3mm red and blue LEDs. And so I removed the 2 surface mount LEDs and I soldered on 2 red and 2 black wires for the anodes and cathodes of the 2 3mm LEDs. Again, these wires were about 6 to 8 inches in length. In preparation for soldering the LEDs, I pushed on 4 1-inch pieces of heat shrink tubing onto each of the 4 wires. I use a lot of heat shrink tubing in this project, but if you don't have any, you can use some regular electrical tape to insulate the wires and protect them from touching each other. I then soldered on the 2 LEDs, red wires to the anodes, black wires to the cathodes, and I pulled the heat shrink tubing forward all the way down to the LEDs and heated it up to shrink the tubing. Next, it was time to solder on my standard push button on-off switch. And so, like everything else, I tinned both tabs of the power switch and I soldered on 2 red wires onto this push button switch. Next were the speakers. With the speakers I soldered on about 10 inches of red and black wire to the red and black wires respectively. I gave it this extra length because I didn't quite know how the wires were going to fit through the housing yet. Again, I protected these solder joints with heat shrink tubing. Now that all of the wires have been connected to each of the components, they should be twisted together, soldered, and protected by either heat shrink tubing or electrical tape. I did not yet solder the speakers to the amplifier yet because the wires would have to be fed through the housing before they get soldered onto the amplifier. And so we'll do a quick review of the electronic assembly before we jump into the housing. Power is coming into this module here, which is going to be connected in the housing. From this, it's going to be a regular barrel connector. So this is going to attach to these 2 wires right here. Out of this, we are charging the battery. And the battery is coming into these 2 inner wires right here. And of course, the charge out of the battery is coming out of this board also, because you may remember this board protects from over discharge as well as overcharge protection. This module is a TP4056, and out of this module we are going to our Bluetooth 2.0 module right here. This is an XS3868 OVC 3860 and its breakout board. I'll flash on the screen the eBay listing that you can get both of these. You can actually buy them assembled also. Power is coming in from the charger module through this green wire going into this micro USB that I've glued into place, and out of this, and so this is the module that's receiving the music. It's sending the music out the speaker wire here, which is going over to the amplifier. Here's the amplifier. This is a PAM8403, a 3 watt plus 3 watt class D amplifier. The audio out of the Bluetooth comes in here. So this is the input low signal, it's getting amplified, and of course on this end it's going to be connected to the speakers. I didn't connect them yet permanently because they would have to be cut either way to go into the housing, and so that's it. That's a quick overview of what we have. Really quickly again, batteries, we've got two in parallel being charged by this module. Here is a simple on-off switch up here, so that has to get mounted in the housing. These two status LEDs I took off the board and they have to get mounted on the housing. The two speakers have to get mounted on the housing, and all of this then can get stuffed inside the housing that we make. And so it's time to get over and move over into the housing. Let's look at that build. For the housing, I just need two 1.5 inch elbows and a 1.5 inch piece of PVC pipe cut to 3.5 inches long. I'll have a link in the description down below with a full parts list for the housing and of course the parts list for the electronics build. The diameter required for the on-off switch is 0.269, and so what I might do is just drill a 1/4 inch 0.25 and just ream it out a little with my hand so that this fits nicely inside. With this power connector, it needs a 0.35. I think I'll drill 0.375. It's a little larger, and then just use a hand file to file some of the hole down so that we can get a nice fit for this power connector. And so I marked a spot on the back for the power connector, and then I marked a spot on the top for the red and the blue LEDs. I also marked a spot for the power button. I then marked 2 holes at the top and 2 holes on the bottom to screw the 2 elbows to the straight pipe section. We are now ready to drill holes. The hole sizes are 1/8 of an inch for the LEDs, 1/4 of an inch for the power switch, 3/8 of an inch for the barrel jack connector, and 5/16 of an inch clearance holes for the mounting screws. I started all holes out at 1/8 of an inch and gradually got larger as needed until I came to full size. All holes were countersunk with a countersinking bit except for the hole for the barrel jack connector. The countersinks allow better access to the power button and make the LEDs more visible. It also allowed for the binding screws to be flush mounted. As for the barrel jack connector hole, I just rough marked with the Sharpie the hole size for the barrel jack, and I used my rotary tool and some files to make the hole size as close as possible. Looks like it's going to fit just fine. Now it's time to mount the electronics into this housing, and so just to be sure I marked each hole 1, 2, 3 and 4 so that it would reassemble exactly the way it was. And now to get the nuts and bolts in position, these are the exact screws that I used. They are 632 3/4 inches in length with nuts. I screwed the nuts onto the bolts for all 4 positions with my hand to get them positioned exactly where they should be. I did this only on the tubular section, only such that I could position the nuts so that they could be glued into place. Here I am gluing them into place. Now it is time to wire the barrel jack connector, so I wired a red wire to the center terminal and a black wire to the outside terminal. And now to begin mounting all of the electronics into the housing. I'm starting with the barrel jack connector. I applied a generous amount of glue and just pushed the component into place. Next is the on-off push button. Again, I applied a generous amount of hot glue, making sure not to get any glue onto the button itself so that it could still turn on and off freely. This also was pushed firmly into place. I added more generous amounts of hot glue with this lollipop stick for strength. Next to go in were the LEDs, and so in a similar fashion these were just hot glued and pushed firmly into place. Again, I applied generous amounts of hot glue for strength. I pushed the left elbow into place, lining up the holes and making sure to match the numbers I had written earlier. The 2 screws for this end were cut down to size and inserted into this end. I then fed the wires for the left speaker through the left elbow so that they could be soldered to the amplifier on the other side. I fed the wires for the right speaker through the right loose elbow also so that it could be soldered to the amplifier. On all of these modules I applied hot glue to where the wires were soldered onto the boards. This provides strain relief as well as insulation. I then soldered the left and the right speakers onto the amplifier, red to red and black to black in both cases. Again, I pushed on 4 pieces of heat shrink tubing. I tinned the ends of each of the 4 wires and then they were soldered together and the heat shrink was heated to shrink on. At this time we're at a point where we can just hot glue the speakers into place, but first I put some of this old sponge behind each speaker. This helps absorb any sound that may reflect backward from the speaker and reduce or eliminate any tinny noise coming from the speaker. When applying the glue to the speaker, be sure to only get glue on the metal part of the speaker and not the internal paper portion of the speaker. I did the same thing with the right hand speaker. Just as an added layer of protection, I wrapped each of the modules with electrical tape just to make sure that everything is insulated from each other. And now it's time to get everything into the housing. First I pushed the batteries in, and then I pushed the Bluetooth module right in next to that. The charging module and the amplifier, and of course some pieces of sponge, all can fit into the elbow that still remains. Of course, in retrospect, I had the idea of adding a 1/4-20 nut. A 1/4-20 is the standard thread size for a tripod stud. So using this wooden ruler to protect the components inside, I drilled from 1/8 right up to 3/8 drill size. I then enlarged the hole with a file, getting it as close to size as possible. After getting the hole very close to size, I press fit the nut in with a large slip groove pliers. Since this nut was going to be carrying the entire weight of the speaker, I decided to glue it in place with 2-part epoxy. I then applied the 2-part epoxy to the inside of the nut, making sure not to get any on the inside of the thread. I do have to say at this point also that I did forget to drill for the green power LED, and so I drilled and countersunk and mounted the LED in the same way that I did the other LEDs. It is now time to paint, so I masked off the speakers, the barrel jack connector, the LEDs and the power button. I used masking tape and heat shrink tubing on the LEDs. I used standard flat black spray paint and I think it came out quite nicely. To protect the speakers I used these 1.5 inch to 2 inch PVC adapters. I just had to figure a way to attach them to the main housing. I painted them the same black color and came up with this 1/2 inch wide sticky back foam. I peeled the backing off the foam and stuck it to the inside of the 2 inch section of the 2 inch to 1.5 inch adapter. There was just enough foam to create a nice interference fit and push nicely onto the housing. And finally, the power charging cable. For this I used the other half of the green micro USB charging cable. I stripped the outer jacket, and as we know from earlier, the outer braid is the negative and the orange wire is the positive. So similar to my other splices, I spliced this barrel jack connector red to orange and black to braid. They were soldered and covered with heat shrink tubing. I plugged it into a standard plug-in charger, plugged it into the speaker, and it is charging. When it is fully charged, the red LED goes out and the blue LED comes on. And that's it, it's complete. And now it's time to test. I'm going to play a few seconds of this royalty-free music so that YouTube doesn't ban this video. And we're going to listen to a few seconds on my Bluetooth speaker, the Beats Pill, and the Bose SoundLink. Take a listen, we'll come back and then we'll wrap it up. don't know about you, but I did hear a clear difference in the sound coming from all three. And there was a clear winner. The clear winner was the Bose soundbar. It definitely had a lot more bass and just crisper, cleaner sound. But I have to say, in listening to the Beats pill and my speaker, and hopefully your speaker, if you make one, if you know, it wasn't too drastically different. I would say the Beats pill is a little better. If you added up the price of all the components for this speaker, it is probably 1/10 or 1/20th of the price of the Beats pill. And so we have a clear winner, the Bose soundbar, probably the Beats pill second, my speaker third, but it's still an excellent speaker with excellent sound. Definitely worth making. Thank you for taking time to watch this video. Give it a thumbs up, subscribe to be automatically notified of upcoming videos. Follow me on social media. See you next time.